Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you can find workshops and exercises to learn about AWS services. And today we are going to talk about how to write an Glue ETL job using PySpark. This workshop is broken down into two parts, 1 and 2, and you have to do these two parts in sequence to complete the whole workshop. But it's a very interesting one, and you are going to understand the syntaxes and methods within PySpark to able to perform an ETL job using Glue. So before I jump on to details of the workshops, let's try to understand some of the fundamentals involved during the workshop. So one of the first fundamental is your data lake in AWS using lake formation. So the purpose of the data lake is pretty straightforward. It is used to store and manage your data, and it also provides access control over your data, and most important, it catalogs your data. That means whenever you put any data inside data lake, it is cataloged with a table name and a schema defined behind it. So we are going to configure in this workshop a small data lake, which will be used to catalog the data stored inside S3 and then also used to control access to it. So that's the first part of this is like a part of the component you will build as a part of the workshop. Now, the next part is writing a glue job. Purpose of the glue job is to perform an ETL operation, and it works in conjunction with catalog. So it can use your catalog as a source data. It can perform then it can perform transformation on the job, and that transformation can be written in many languages. PySpark is one of such scripting language for transformation, and then the job can write back data again to the catalog. Now, catalog can source data from various places, like it can have data from S3, it could have data from relational database, it can have data from Redshift, it can have data from many sources. But in this case, we are going to use S3 as the data source to keep the cost low and keep things a little simple. But we are going to write a glue job in this case, which will take data from the catalog source table, will perform the transformation using PySpark, and then write back to the S3 table, S3 storage. And such jobs can be either scheduled or you can run based on the event. But today we are going to manually run it for the workshop purpose. So next important part of the workshop is PySpark. And PySpark is the language, is the script we are going to use for the transformation purpose. And this is actually a Python API for Spark, which is primarily designed for big data processing. So it is designed to handle transformation of the big data. So we are going to use this language and learn various capability of the language from the extraction, transformation, and loading point of view. So in extraction, we'll primarily learn about how to check the schema, how to query the data, how to filter the data, and so on and so forth. During the transformation, we will learn how to do column level, row level processing of the data, how to aggregate the data, how to work with multiple data sets, how can we merge one or more data set into a single data set, how you can split a data into multiple data sets. And finally, we move on to the third part, which is loading part, that once I have performed the transformation, how to write data back. So we are going to spend, in fact, the whole part 2 of the workshop is focused on PySpark to help you understand how to perform extraction, transformation, and loading. And finally, when you are doing certain development, you need a development environment. And we will use Glue developer endpoint to create a development environment. In this case, what we will do is that we'll use our Jupyter notebook as a development environment. But actually, what happens is that Glue provides a feature called Glue Developer Endpoint, which provides a Glue Spark environment and provides native connectivity or integration with a Glue catalog. And in this environment, you can run your, say, PySpark code script to perform big data processing. In this case, we are going to use Jupyter Notebook as a developer ID, but you will, yeah, I mean, there are instructions and there are methods available to integrate, in fact, any other ID with developer endpoint. In fact, I'm thinking to create a small exercise some point of time where I tell you how you can integrate other IDs with a developer endpoint. But today, in this workshop, we are going to use Jupyter Notebook as the ID. So primarily 4 components, as we mentioned earlier. So we will set up a data lake, then we will create a Glue job. We will use PySpark as a language for big data processing, and then we are going to use Jupyter Notebook along with developer endpoint as a development environment. So let's put all these things together and understand what we are going to do in workshop part 1 and workshop part 2. So if we see what we are going to build today in part 1, so in part 1, we are going to store data inside S3. Then we will use crawler to catalog the data. So that creates our data lake. Then we go and set up a developer endpoint. And this developer endpoint will help us understand or run PySpark code in a development environment. And then we are also going to set up a Glue job, which will simply do the merging of these 2 tables and write back to the S3 bucket. So this is what we are going to do in part 1. So in part 1, you learn setting up a mini data lake, setting up development environment, and creating a Glue job using the PySpark. So that's the learning for the part 1. In part 2, we will focus primarily on PySpark. So using the same development environment, now we'll work on the developer endpoint more, and we'll use SageMaker Notebook, Jupyter Notebook, to actually run all 3 types of operations. So in this, we'll try the extraction operations, transformation operations, and loading operations. So that's how we have split our workshop into 2 parts. And yeah, I mean, you learn all the 4 components I talked about earlier in the presentation. So let's see where we can run this workshop. This workshop you can run using these two URLs, and we have provided description of this URL in the description below the YouTube video. Okay, so let's jump onto these workshops, and these workshops really provide a very detailed sequence instructions to complete the scenario. So let's jump to the workshop. So here is our workshop, and it is published at our aws-dozo.com website. This is the website where we publish all our workshops and exercises. Yeah, we publish roughly 1 or 2 exercises or workshop almost every week. So here we go. So we start with the part 1 first. So we click on this link here to start the part 1 workshop. And you can see in the part 1 workshop, we have steps like first you go and create your data lake. And then once you have set up the data lake, then you create a developer endpoint, which is used to create your development environment. Then you try some PySpark coding with the development environment just to test it, just to get a feel of it. And then you finally use the same code you have built over here in your development environment to create the Glue job and run it. Then you move on to the part 2, and then in part 2, actually, you primarily focus on PySpark. So let's start with the part 1 first. So we click on the prerequisite. You need to have an AWS account to run this workshop. If not, then you might want to create a trial account using this link. Then we talk about the data used in this workshop. And we are using 2 data sets here. One is the customer, second is the sales. And these are different properties of this data set. Okay, so these two tables we are going, or these different data sets we are going to use for our workshop. Then we go and create some IAM role, and as you know that AWS services use role-based authorization. So here we are going to create some role for the Glue service, so that different construct like crawlers or Glue Job can use that role for the authorization purpose. So we simply go and create a role, and that role is called Dojo Glue role, and this role is for the Glue service. Okay, and this role then will be used by the Glue building blocks later point of time. So once we have created the role, we create the S3 bucket, and this is the bucket where you keep your source data, like your data lake data. Okay, so generally you will like to create some kind of data ingestion ETL to upload the data, but in this case, since we are trying to learn more about how to create the Glue job and how to use PySpark as a language or script for the programming, we have not focused on data ingestion at this point of time. But if you are interested to understand data ingestion, please write to us. I'm happy to create a separate workshop or exercise for that. So what we're doing here is that we are creating a Dojo data lake bucket, and in that bucket we create two folders, data and a script. And a script is used to store your Glue job script and a later point of time, and data is where we keep our data. So in data folder we create two more folders called customers and sales, and then we simply upload customers and sales CSV files to these folders. So your sales.csv goes to sales, and your customers.csv go to customers folder. So these are the two different files we are dealing with, or data sets we are dealing with. Then we go and configure our data lake in lake formation. So we go to the lake formation. We first add administrator to the lake formation, and after that we create a database. First we create a database for the data lake. We give this a name called Dojo database. We point it to the data location into S3 bucket. And after that, once we have done that, we also register this location as the data lake location within the lake formation. After that, we have a database created in data lake. Now our lake formation. Now we need to go and catalog the data. So data is inside S3, but that has to be cataloged so that it can be given a name inside data lake, and data lake can also identify the schema behind the data. So for that we run the crawler, and we go and configure the crawler into. So you have to go to the Glue. You have to first give the permission, because in AWS every service needs to have permission to perform certain job, and in this case the table and the way lake formation work is that each of the database and tables needs to be given permission on before any of Glue job or crawler or end user can see or work with the data. So in this case, since crawler has to create table inside database, we are providing certain permission to the crawler role. So we simply go here and say, remember we created this Dojo Glue role earlier, which is used by the crawler. So we simply give this role permission to create and alter the table inside the database. We give that permission. And after that, we are now good to go and create the crawler. So we go and say, let's go to the Glue console, add a crawler, give this a name called Dojo crawler. And they say, okay, this crawler will ask what is my data source from where I'm going to see data for the catalog generation. And you simply say my data is into S3, and then you provide the location of the folder where your customer and sales data are. And after that, actually it says, do you want to add another data source, which you are not, because you have only one data source. Then I'm providing Dojo Glue role as the role which this crawler can use. And now this role also has permission to create table inside the database, so crawler will have no problem cataloging the data. And then simply we are going to run it. And generally in production environment, you will like to run it based on the schedule or even sometimes based on the event. But right now we are going to run it on demand. and then saying, okay, where does the crawler put the output? And output means the catalog of the data, and say put the catalog of data or output in Dojo database. And then you simply go and run this crawler. Once you run this crawler, it takes a couple of time, sometime minutes to finish the crawling. And once the crawling is done, you can see your two tables, customers and sales, created inside Dojo database. And these two tables actually represent the data stored inside S3 bucket. Actually, you can click on these two tables, you can see schema of the data inside S3 bucket. So having created the table, now we need to set up permission for this table, because the Glue job has to work with this table to be able to perform the transformation and query and those kind of operations. And Glue job is going to use Dojo Glue role as a role for the authorization. So this role needs to have permission on the table. And that's what we are going to do next. So what we do for that is that we go to the lake formation, we select the table. First, we select the sales table, and then we say for the sales table, for the glue role, give select permission. So this role now has select permission on the sales table. And similarly, we ask them to provide like this glue jobs to provide glue job, Dojo glue role, not job, Dojo glue role to provide select permission on the customers table. So we provide this role permission to both of the tables. Now our lake formation is ready because we have our data, we have our permissions configured. So now we focus on to development now. So first we create a development environment. And to do so, we have to create a developer endpoint. So you go to your Glue console and say, I want to add a developer endpoint. And at this point of time, again, it will ask which role you want to use. And then we are simply piggybacking on the one role only, which we created earlier, this Dojo Glue role. So simply developer endpoint is going to use this Glue role. And then again, we are good because this role has permission to read data from the table. So my scripts, my jobs will have no problem. My script will have no problem. Whatever script I write inside my developer environment will simply use this role-based authorization. So I will have no problem querying my data. So you go and create a developer endpoint. There's no networking requirement here because I'm not talking to any relational databases at this point of time. So we can simply skip that part. And then my developer endpoint will be ready. Generally, developer endpoint might take some 8 to 10 minutes to be ready because it's really creating a PySpark environment, really creating a Spark environment behind the scene, which has a connection with your Glue catalog. So once my developer endpoint is ready, I can launch my SageMaker notebook or Jupyter notebook. And this new Jupyter notebook we are going to use as our development ID. But you can actually choose your own developer and you can use your own ID to work with this developer endpoint. But in this case, we are simply going to use Jupyter notebook for ID. So we simply go and launch a Jupyter notebook. Again, it will ask for certain configuration that what developer endpoint you want to use. It needs to create its own role for the authorization. We are not providing any networking detail here because again, we are talking to S3 bucket. We are not talking to any relational database where we need to talk to a VPC resource. So we are simply skipping that part. And then we create the notebook. And my notebook is created. So once my notebook is created, we all know that yes, my developer ID is ready. So in the next task, what we do is that we open this notebook, and then we'll see how to open the notebook, and then how to create a new file into the notebook using the PySpark environment. And then after that, we start trying some code. So we'll write some code which we'll use to create a Spark session, and then also create context, GlueContext. And we need to have a Spark session with the GlueContext because you want to have Spark session because you want to run your PySpark task or scripts. And then you need to have a GlueContext because your PySpark script should be able to talk to the Glue catalog. So in this case, we are simply creating a GlueContext with the PySpark. And this is the script for that. You do that, and once this session is created, it says, hey, this session is available now. Then we are running some scripts to query the data. So you can see that, and Dojo database, we had sales and customer both data. So we are simply running this script over here to copy the data from the source. And once we copy the data from the source, actually you can use a method called print schema to see the schema of the data. So you can see that I'm running print schema to run the schema of the data. And then if you look at this to schema, actually what you'll find that it has a customer ID as a common field. So what we are going to do is that using this customer ID, we are going to merge these two data sets together. So in order to do so, we will run a script like this, which will simply go and merge these two data frames together based on the customer ID. And when you do that, actually, it creates a duplicate customer. It's a duplicate column, not duplicate column. Yeah, it's kind of duplicate column called dot customer ID, which we don't need. So we are simply using this method to drop that particular column because we don't want two columns with the same value. It is adding no value to us. And once this part has been done, then we move on to the next part. So if you look at this thing, actually, this was our data extraction. This was our transformation, where we are merging two data together, and then we are loading the data, because now we are writing this write method to write this data back to S3 bucket in the customer sales folder. And this time we are converting this JSON, this CSV data into JSON. So the source data was in CSV file. Both sales and customer data were in CSV file, but using this method, we are converting this into JSON file. And this was like just to show, but you could have kept the same CSV format, or you could have selected some other format like Parquet or CR Avro. Okay. And then once you run this script, you can go ahead and check that, under my Dojo data lake data customers folder, a new data has been created. And if you open the data, you will find that the same CSV file now is converted into a JSON file. So this was to show that how you do development inside Jupyter Notebook with PySpark. We are going to cover it more in the part 2, but we kept some into part 1 just to demonstrate the development environment. Now what we are going to do, that whatever script we wrote over here, we are simply going to use that script and convert into a Glue job. To do so, we go to the next step. And in the next step, we go back to the Glue catalog, where we simply go and add a new Glue job. And in the Glue job, you give it a name called Dojo job. Then the role is Dojo Glue role. Again, this role has permission on data lake, so we should not have any problem running this job. We select this is a Spark job, and then we select Spark with Python 3 as a version. And in this case, saying that you can actually generate your script as well, or you can import an existing script. But we are saying we are going to write a new script in this case. So we say, okay, fine. If you're writing a new script, where do you want to keep that script stored? Because Glue is serverless. So say, let's use this Dojo Data Lake script folder. Remember this folder we created earlier? Let's use this folder to keep our script. And once you do that, it creates a Glue job with this kind of blank area where you can go and create your script. And then what we are doing is whatever script we tried into PySpark just to learn how the development environment works or how you can run your code over there. We simply took that whole code one by one from there and write it here. Simply copy, paste, nothing more than that. And we do that, and then here is the code snippet. You simply write that code, and once you write the code, you save the job, and then finally you run the job. When you run the job, it will take some time for a job to finish. But once job finishes, again you can go and see to the data lake that your file has been created, and this file has been created by the Glue job. So this was very much part 1 of the workshop, where The idea was to help you understand how to set up a data lake, give permission to data lake, and then how do you create a glue job. And whatever development you want to do for glue job, if you want to do some kind of unit testing, statement by statement execution, how do you use developer endpoint with PySpark, developer endpoint with Jupyter Notebook to perform that kind of task. So at least at this point of time, you say, hey, I think known enough. Now I don't want to do anything else. You can very well clean up your resources and say, okay, I'm done, and you will not incur any cost due to resources created by this workshop. But if you're really interested to understand PySpark in greater detail, then I will recommend you to click on this part 2 of the workshop and go and learn about PySpark scripting. So let's jump onto the part 2 of the workshop now. So when I click on that, you can see here that you cannot do part 2 unless you have done part 1, because it uses part 1 configurations to use part 2. So it needs data lake, it needs developer endpoint that you created in the part 1 in order to finish part 2. So in this case, we are going to learn about 3 types of operations: extraction, transformation, and loading. Okay, so let's start this workshop. So this is the workshop, and it is a little smaller than the previous workshop, only 7 to 8 steps involved. Again, the prerequisite is pretty straightforward. You cannot just do this workshop unless you have finished the part 1. So kindly finish your part 1 and then come to part 2. Then you go one by one. So first we learn about how to check the schema, and some of this you have seen into part 1 as well. So all you do is simply launching a Jupyter Notebook, a new file into Jupyter Notebook, and then at this time you're giving this notebook file a name, say check schema, and then you are simply creating a GlueContext and Spark session. And once you have done that, you are loading the sales data. And then once you have loaded the sales data, then you can run a statement like print schema and count print schema you use to again check the schema of the data, and count to check number of rows in the data. So generally this method is used in PySpark in your developer endpoint if you want to on the fly want to know how many rows this data has, or what is the schema of the data. If you have questions like that, you can use these 2 scripts to check the source data schema. Okay, so in this particular task, you simply check the schema, nothing else, and then you simply go and close the execution of this particular notebook file. Then you move on to the next part, which is query data from the source. So in this part, we learn how to query data from the source and also how to filter data when you query at the source. So again, the same way, you create a new notebook. At this time, this is called query notebook. First, you go and create the context and Spark session. And then we are simply loading the source, loading the sales data or data set from the Dojo database. Then you run this, use this show method, and the show method will show you the top 20 rows of the data. So you can see the top 20 rows of data using the show method. If you want to see less number of data or a fixed number of data, then you can also pass how many rows you want to see as a parameter. You can also use a head method, and it provides actually data in a different format. I mean, just simply run it, and you'll see difference between show method and head method. Both provide you data, but head shows data is an entirely different different format. Then many times you say, okay, fine, I have got my source data, I see it here, but I'm not interested in all the columns. I'm interested in certain columns only. So for instance, I'm only interested in order numbers and sales. In that case, you can use this select field method to actually filter down your data query to only order numbers and sales. So you can do that as well. So this shows you how you can do filtering based on the columns. Similarly, what you can do is that people also do row level filtering and say I'm not interested in again the entire row of data, but I want to see data with certain values in certain rows. In this case, all I'm saying is that I'm interested in only that data where the sales is more than 12,000. And again, I'm showing you a simple example here, but you can create a very complex criteria over here. We're using or and kind of combination where you can say I want to filter my data based on certain criteria. So this is the example where you can use filter.apply method to filter based on criteria for the rows. So this was a task which helped you understand how to query your data from the source, how to see your data, and also how you can filter your data based on the rows and the column. Now let's go to the next task where you learn how to update the data. So in the update data, again, we go and create a new notebook called update, and then we create our GlueContext and Spark session. And this time we load a different table called, a different data sets called, say, customers. And in order to manipulate this data, actually, what we are trying to do here is we're saying the customers data has got two fields called contact first name and contact last name. And we want to create a contact full name by concatenating these two columns. So do so, you create a Python script where you can do this kind of column manipulation or column aggregation or column concatenation to create some new columns altogether. And then we simply use this map.apply method along with this along with this Python method or Python function to manipulate the data. Now, once I have created this contact full name, to be honest, we don't need this contact first name and last name. And in that case, you can use this drop fields method to drop the contact first name and last name from the data set we are using. And here is another example I have used where I'm talking about, like for instance, here in this case, we are using a Python function to take out the domain name from the email ID. Yeah, just as an example. And purpose of this function to show you that actually you can write a very complex Python code for data manipulation. Like in the previous case, you did simply adding two columns together, but in this case, you're really writing some kind of indexing and parsing of the data and so on and so forth. So actually, you can do this kind of complex. Well, this is not again very complex, but yeah, you can really write a very complex logic using Python for data transformation. Again, you simply use map.apply method to apply this function for the data manipulation. If you want to rename certain column from one name to another, so for instance, you want to rename territory into say region. Territory is a field inside our data frame, and we want to simply rename into region. If you want to do that, you can use this rename field method for that purpose. So this was some of the examples of data manipulation where you are using Python functions to be able to manipulate data at the column level. Now, there are other methods available for data manipulation, and one is called aggregate function. And let's talk about aggregation functions now. So we create again a new script file called aggregate. We then create simply GlueContext and the session. Then we load the sales database and the sales data set. And then you can see this cross-tab method. Using this cross-tab method, you can put your product line and deal size together in a tabular format where you can see each other in a relationship, in a perspective. In perspective. So this is a very interesting thing. For instance, you want to see that does product line and deal size has any relationship? If you want to put that kind of, you want to see that kind of view, you can use this cross-tab method. Similarly, if you want to say sales is a numeric field, and if you want to run this describe method on the sales, then it will show you all the statistics of the sales. So for instance, max sale, minimum sale, your average sale, your standard deviation of the sales, that kind of information it will show using the describe method. Similarly, you can also use group method. So suppose if you want to group, you want to group by product line, and all you want is count. So you want count by product line, for instance, count of the record by product line, then you can use this group by method. You can do certain else as well. For instance, look at this example. It is selecting, it's looking at product line wise, quantity ordered, minimum, maximum, mean, and sum. So you can do this kind of query as well, whether you want to group by, but you want to see minimum, max, mean, and sum, and that kind of aggregation. You can do that as well. Actually, you can put multiple aggregation into same line. And this is one example. We're saying, hey, let's group by product line. But then for the quantity order, I want to see the mean of it. For sales, I want to see the sum of it. And for price each, I want to see max of it. So this will give you product line wise multiple aggregations, multiple types of aggregation across different columns. Yeah, you can do that as well. And finally, this one is use order by method to order your data in certain way. So this was some of the examples where you can see how you can use different methods for running statistical analysis or aggregation on your data. The next one is merging and splitting of data. Some part of this you have also seen in the previous workshop. Previous part of the workshop. But we'll talk few more things over here. So we are creating again a new data set called multi-data set. We create a glue connection and Spark glue connection, say GlueContext and Spark session. Then we will load both sales and customer data. We check the schema of the data. Then we decide to join this two data based on the customer ID field. And again, this thing we have done earlier. And then we simply go ahead and drop the dot customer ID field. So basically what we are doing here so far is that we are joining these two data sets based on the customer ID. So it's like column wise joining of your data. Similarly, you can also split your data. And you can split, so you saw the case of joining here based on the column ID. Now the next example is where you can split your data based on your column. So for instance, this is my sales DF. I want to, or my sales data, I want to split into two. And one will have these three columns, and that will be called product DF. And the rest of the columns will go to this DF. So you can run script like this, which will simply go and split this into two, column-wise split this sales DF into two data frames, product data frame and rest data frame. You can check the schema of these two data frames over here. Similarly, you can do a row level split as well. So you like split fields was column level splitting. Then split rows you can use to do a row level splitting. And in this case, we want to split our sales DF based on the sales value. So wherever the sales is more than 5,000, we say it is sales 5,000 plus data frame. And for less one, it is sales 5,000 minus data frame. So you can run this kind of script to break your sales data into two different data frames based on the sales value. And again, you can see the schema of the data and top rows. You can also use something called union method. So suppose you have got this sales plus and sales minus two data frames. Suppose you want to merge it back, row-wise merge it back. Then you can use this union method to merge two data frames together row-wise. So that's also you can do. So this is another example of data manipulation where you're working with more than one data sets together, and then you're using two or more data sets to basically merge them column wise. This was the example of merge them row wise, and then these two were example of how to split data row wise and how to split data column wise. Yeah, again, very important task when you're performing data transformation. Finally, once you have performed the data transformation, you have to upload the data back. And for that, we are writing a script called load data. Again, we do the same method. Again, this part you have seen, a part of it you have seen in the first part of the workshop as well. So you're creating a GlueContext here and a Spark session. Then you load the sales data. Then I'm simply using the select field methods to create another data frame called, say, product line data frame, which is basically using only 3 columns from the sales data: product line, deal size, and status. And then I simply write using this write method to write this data back to S3. And this is my location. This is my location in the data set. Sorry, in the S3 bucket. And again, here I'm converting my CSV file into JSON. Similarly, so this is an example of writing back to S3, but if you want to write back to, say, relational database or Redshift, you can do that as well. And actually, method does not change much. You again use this write method only, but in this case, you actually your data, your target location, like target relational database or Redshift location, should be configured within your Glue. You should have a Dojo connection defined, and you can use a script like this. We are saying, hey, I'm going to use the Dojo connection, and in this database, simply write this table, and this is the location which it can use for any scripting purpose. So using this method, which is not very different from S3 method, you can write data to a JDBC, ODBC endpoint, like your relational databases or Redshift. So this was about how you can do the data writing back using PySpark. You learned about writing to S3. You saw how to write it back to a relational database. Then that actually very much finishes the workshop. You then can go and clean up all the resources used in the workshop, because you don't want to incur any cost once this workshop has been completed. So that finishes the workshop. And I hope you like it. And if you like, please click on the like button. Please click on the subscribe button if you want to learn more about this kind of videos, to learn about AWS services using workshop and exercises. In AWS Dojo, we provide many workshops and exercises like this. You can see the list of workshops over here. Similarly, you can see a list of exercises over here. Each of these workshops and exercises you can implement to learn about AWS services. If you have any feedback, suggestions, or requests for new content, you can reach out to us by writing a comment in our YouTube channel, or you can also click on this Contact Us tab in our AWS-Dojo workshop Dojo website to provide us feedback about the content and the video. Hope you enjoy it. Have a nice day, and see you again next week. Thank you. Bye-bye.